Today's lesson is on counting principles, and then we're also going to talk a little bit about scientific notation. So we're going to start here. We can use powers to count the number of sequences possible for repeated choices. So in other words, things like a combination lock that requires a sequence of 3 numbers between 0 and 9 to open. How many different possible codes would there be? Or a test that has 10 true and false questions and 8 multiple choice questions. How many different ways are there to answer that test? We can use powers to actually help us with that. So while some of these problems seem difficult to figure out, because there are so many different combinations, we can use what we know about powers to make these problems a lot easier. So for example, any 2-letter acronym, an acronym is something like FBLA, Future Business Leaders of America. There are many, many 2-letter acronyms, but we want to know how many are there total. So we could start by listing some. So we could start by listing AA, B, C, maybe D, E, just randomly listing them. We don't need to know what they mean, but just different order of letters that we can have for those 2 letters. So get your 15 down, and then we're going to switch over to this next slide. So because listing all of those 2-letter acronyms would take forever, let's figure out if there's a shorter way to do this. So let's think about these in an organized manner. So let's start alphabetically, and I'm going to start writing them in alphabetical order. So AA, AB, AC, AD, AE, AF, AG, AH, and so on. Then so it would be 26 going over that way. Okay? Then I would go to the B's. BA, BB, BC, BD, BE, BF, BG, and so on, all the way down to Z. So it'd be 26 going down for the B's. We could move to the C's. CA, CB, CC, CD, CE, and so on. So it'd be 26 that start with C. We could do the same thing with the D's. DA, DB, DC, DD, and so on. We could do it with the E's. Okay, so what we're going to have to do is going across, we're going to have the second letter. We need to count each, we need to use every letter in the alphabet once for the second letter. And then we also need to use every letter in the alphabet for the first letter. So that's what we're doing going down here, using A for our first letter, then B for our first letter, then C for our first letter. Okay, so what we find here is that there are 26 choices to choose, 26 choices for our first letter. There are 26 choices for our second letter. So to find out how many that would be, we can look at this kind of like a multiplication table. If there were 5 going across the top and 4 going down the side, that would be 5 times 4, so there would be 20 boxes to fill in. Well, here we have 26 going across the top and 26 going down the side, so that's 26 times 26, or 26 squared. And if we use our calculator, we get 676 total acronyms. Okay, so that's our first example. So we do have a shortcut for this. We surely do not want you to write out all of those every single time. So our shortcut is if there are n ways to select each object in a sequence of length L, then n to the L different sequences are possible. So you can think about it like this. We had 26 ways to choose each letter. Okay, and it needed to be 2 letters long. So we wrote 26 to the 2. Makes perfect sense. All right, so let's try some problems here. And I really like to set these up. I'll show you a way that works well for me to set these up. So we'll start with number 2 here for our practice. It says in an apartment building, each apartment has a building number from 1 to 9, followed by a letter A to F. So an example would be 1A, maybe first floor, apartment A. Okay. So we would like to find how many different apartment designations there are possible in this building. Okay, so each apartment gets a number designation and a letter designation. So we have to think, okay, how many numbers do we have to choose from? Well, 1 through 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 choices. And how many letters do we have to choose from? A, B, C, D, E, F. That's 6 letters. So we have 9 times 6 ways, which is 54 total ways. So 54 designations. All right. So that was pretty easy. And my kind of shortcut way here of doing this is saying, okay, I have 2 spots that need to be filled in. How many choices do I have for the first spot? How many choices do I have for the second spot? So you'll hear me say that a lot. Okay, let's try number 3. It says a combination lock requires a sequence of 3 numbers. All right, so I need 3 numbers. 1, 2, 3. 0 to 99. Now here's where it gets a little tricky. If I include 0, I really have 100 numbers to choose from because I have 1 to 99, that's 99 numbers, and then also 0. So that's 100 numbers to choose from for the first one. I have 100 choices for the second number and 100 choices for the third number. So that would be, as a power, 100 to the third. If I actually punch that into my calculator and figure out what that is, I would get 1 million. Oops. 1 million combinations. Okay. Number 4. Suppose a standardized test has 20 questions. Whoa. And each question has 4 choices. And then we also have 10 questions with 5 choices. So I'm going to kind of scoot up here a little bit so I have a little bit of room to work so I can kind of get an idea of what I want to do. I have 20 questions with 4 choices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, dot, dot. Okay, 20 of those. For the first question, I have 4 choices to choose from. I can choose A, B, C, or D for that multiple choice. Same thing on the second question, third question, fourth question, fifth, sixth, and so on. So I have 4 choices all the way there. So the way that I'm going to write that as a power would be 4 to the 20th because I have 4 choices for 20 problems long. Okay. And I also have 5 choices, so the test isn't over. I have 10 more questions that have 5 choices each. So here are my last 10 questions, and each of those have 5 choices. So that's going to look like 5 to the 10th power. Okay, so we have 4 to the 20th times 5 to the 10th. And I believe if we use our calculator here, 4 to the 20th times 5 to the 10th, we can just punch it right in. This is what my calculator tells me. 1.0737 41824 E19. Now, for those of you that don't remember, last chapter we talked about what that E means. It actually means times 10 to the 19th power. So I'm going to write it that way, times 10 to the 19th power. All right? So that's number 4. And that's our answer. That's how many choices we have. It's how many different ways we can answer the test. So maybe one person, maybe Dan answers it one way, maybe Sharon answers it another way, and so on. So that's how many possible different ways that we can answer that test. Number 5 is kind of the same idea. I'm going to let you go ahead and try 5 and 6 on your own, and then when you're ready, you can check your answers. All right, so that's it. So when you're done, you can check your answers, see how you did. This is what I got for my answers for 5 and 6. And that is it on the counting principles.